Question 5 says, in the diagram below, g of x is equals to x cubed minus 3x. A and B are the turning points of G. C, O, and D are the three x-intercepts of G. Question A says, determine the coordinates of A and B. So A and B is said are the turning points over here. And what do we know about turning points? We know that they are also referred to as stationary points. This is because stationary means without a gradient or not moving, not dynamic, which implies that they have a gradient of 0, no tilt. So if the gradient is equals to 0, and we know that the gradient in terms of calculus and things that we work with, that is the first derivative. So if we're looking for the coordinates of A and B, we should look for the values of x for which the gradient is equal to 0. So if our function here, we're actually working with g, so let's replace that with g. That means g, the first derivative will be 3x squared minus 3. And we want to solve for when this 3x squared minus 3 is equal to 0. So solving for this, we take minus 3 to the other side, we get 3x squared is equals to 3, and we can divide both sides by 3, and then we get x is equals to, or x squared is equals to 1. Take the root of that, we get x is equals to plus minus 1. So that makes sense since we can see our graph passes through the origin, and it looks quite symmetrical about the y-axis, or not symmetrical, but it looks, you could say, symmetrical about the line y is equals to x because it is an odd function. So yeah, there's that. Now we have the x values, which is minus 1 and 1. Now we need the y values. To get the y values, we put them back into the original formula. So for x is equals to minus 1, we will have y is equals to minus 1 cubed minus 3 minus 1. Minus 1 cubed is minus 1. This will be plus 3. 3 minus 1 gives us 2. So the minus 1 will have, or for a, we'll have minus 1 and 2. And then for x is equals to 1, we'll have y is equals to 1 cubed minus 3, 1, which gives us 1 minus 3, which is minus 2. And b will be minus, or positive 1 and minus 2. Those are the two coordinates.